Angular versus Blazor, a project comparison. To really compare Angular with Blazor, we need to create exactly the same project in both frameworks. We'll use the same architecture of models, services, pages, and components. The project itself will be a simple app to display a page with to-do items. It will have search or filter text box, and the user should be able to check or uncheck completed tasks. We'll start off by comparing the installation process and IDEs. For a fair comparison, we'll only use the free tools available. For Angular, you need to install Node.js, Angular CLI, and a popular IDE like Visual Studio Code. Additionally, you'll need to configure Visual Studio Code with some packages for IntelliSense and formatting of the Angular code. What we notice is that all these items are managed and maintained by different corporations. On the Blazor side, you can install the community version of Visual Studio and select the Web Development package. This is solely developed and maintained by Microsoft. To create a new project in Angular, you need to use a terminal and type out the correct command. In Visual Studio, it's simply a matter of selecting the Blazor project type. There are other good choices for an Angular IDE, but they usually require special setup. Some have limited Angular features, and those with better features require paid-for licenses. But here's a kicker. On a side note, you can develop Angular apps in Visual Studio Community, but it needs to bootstrap your Node.js and Angular CLI installations. When creating the app in Angular or Blazor, we have options of what kind of project it will be. In Angular, we have the default client-side rendering app, and with the latest Angular version, we also get server-side rendered apps. Just as a reminder, a client-side app is downloaded to the client's device and rendered by the client's device, while for the server-side project, the pages are pre-rendered on the server and then downloaded to the client. This places less strain on the client device. For Blazor, we have a couple more project types to choose from. There's None, which is just the old static web pages, then client-side and server-side, and also a hybrid project where some pages are rendered on the server and more interactive pages can be rendered client-side. We create both apps for client-side rendering. Angular comes with a default page with some helpful links. Other than that, there's no other components. You will have to create a menu component, a homepage component, and the to-do list component. Also, to do this right, you'll have to set up the routes to the pages. On the Blazor side, it comes out of the box with a menu, a home page, and an about page without writing a single line of code. The menu is also adaptive, meaning if the device's display is too narrow, the menu will change to a drop-down hamburger menu. However, you also need to create your to-do list component or page and add the link to the menu file. The route is simply the name of your component. In all fairness, later on in Blazor, you'll probably replace the out-of-the-box menu with a more custom menu. But it's nice to have a menu already set up, and you can dive directly into developing the pages. Next, we'll start with the model. The process is pretty much the same for Angular and Blazor. In Angular, create a models folder and add a TypeScript file. Add a type with some properties. It's important that it must be a type, not a class. In Blazor, create a models folder and add a normal class file. Add the same properties. On to the service. The service will use HTTP to get a list of to-do item from a URL. In Angular, you first need to add the HTTP client provider in the app.config file. Then use a terminal command to create a service class in a services folder. In Blazor, add a services folder to your project and add a normal class and interface class. Call them something like to-do-service and I-to-do-service. In Angular, edit the service class and inject a HTTP client. Create a function to get the to-do item list from the URL. In Blazor, edit the service class. Note that it should inherit from the interface class. Add an asynchronous method to get the item list from the URL. Add a HTTP client object to do this. Here we added an extra line to return an empty list if the result is null. We could have done the same in Angular. Since Angular injects the service class directly into the UI, it's set up to go. On the Blazor side, there's two more steps. Blazor uses interfaces to do dependency injection. The reasoning for this architecture is to limit the methods exposed to a UI component. For example, the service class can contain all the CRUD methods and some business logic, but you can create different interfaces for a component that only needs to read the data and another component that needs to edit the data. In any case, edit the I-to-do-service class, and IntelliSense will add the method signatures in the normal service class to the interface. As a final step, register the service in the program.cs file so it can be injected into the UI. Now for the page that will actually display the to-do list. In Angular, we display a loading message if the list is still empty. We add a form to capture search term and save it into ngModel, which is a special model for holding form values. In the for loop, we display the items, but use a filter pipe based on the search term. We'll have to create the pipe separately. Inside the for loop, we display the to-do item component, which will call a function to update the item as complete when it is clicked. Over to Blazor, we also display a loading message if the list is empty. We add an input for the search term and bind it to a variable. Because Blazor is reactive, the filtered items list will change while you type into this bound search term. In the for each loop, it uses the filtered items list, which will run an arrow function to filter the items based on the search term. What we should have mentioned before is that to create the to-do list page in Angular, you have to use the terminal command to generate the component. For Blazor, you can simply add a Razor component to the existing Pages folder. Let's look at the imports required for Angular. You need inject to inject the service, onInit for the lifecycle function, and signal to create the variables used in the HTML template. You need the model, the service, and the to-do item component. You'll also need catch error if the service picks up an error when retrieving the tagged to-do items. Also, there's the pipe we need to create to filter the to-do items according to the search term. You'll need to import the forms module to use the ngModel. Then we specify the selector name so we can use the component like a tag in the app HTML. In Blazor, we added a Razor component to the existing Pages folder. At the top, we specify a page name. This serves as a route, the same name we used in our menu item. We set some interactive rendering options for the component. We also use the model, services, and components. Then we inject our to-do service into the component. In the actual Angular class, we can now inject the service and create two signal variables to hold the to-do items and the search term. We use the onInit lifecycle function to retrieve the list from the service and simply return an empty list if an error occurs. Then, when the user clicks an item, it calls the update to do item function and maps the items list to a new array while checking which item was clicked to update the item's completed status. In Blazor, just a reminder that the HTML and code section are all in one file, while Angular creates separate HTML and code files. In the code section in the Blazor component, we create a search term and list of items variables. In the built-in onInitialized async lifecycle method, we use a try-catch block and retrieve the items from the service, or if an error occurs, return an empty list. Now remember the filtered items we used in the for each loop. When Razor needs to access this list, it executes the arrow function to filter the list according to the search term. In Angular, we have to create the pipe to filter the items. We use a terminal command again to create a pipe. In the transform function, we take the to-do list of items and search term. Then both titles are set to lowercase for comparison, and only the items that includes the search term is returned. Now for the last piece, the actual to-do item component. In Angular, create a to-do item component using a terminal command. This will create a HTML and TS file for the component. In the HTML file, add a list item with an input for the checkbox that displays the completed value. Also add a label for the to-do item's title. In Blazor, you create a components folder and add a to-do item Razor component. Like with Angular, add a list item with a checkbox input for the completed value and a label for the item's title. Both checkbox inputs will call a function or method when the checkbox is changed. In Angular, in the component's TS file, you'll need to import input and output, as well as the to-do model. Set the selector name so the component can be used like a tag in the HTML template. In the class, create a to-do which will hold the item passed to the component. Add a to-do toggle output, which will be sent back to the to-do list page. Create the function that will be called when the checkbox changes. This will emit the toggle back to the to-do list page. In the Blazor component, you should have a using models statement at the top of the file, followed by the previous HTML. Then below that, in the code section, add a parameter that will receive the to-do item passed to it. Create a method to respond to the checkbox change. All we need to do here is swap the bool value. Notice how different Blazor is here. Because it passed the reference of the actual to-do item object to the child component, this child component need not emit anything back to the do list page when the item is changed. The to-do list page will react immediately to the change on the item. Other than that, the CSS files and the final to-do list page looks and works the same. In summary, let's look at the source sizes of these two frameworks. The numbers clearly tell the story. This influences the disk space, copy, and backup speeds. As for the actual lines of code added or modified, we only looked at the to-do list page and components, the model, the service, and configuration lines added. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.